All right, welcome back, everybody. This is a continuation of 3.2a. This is going to be part B, where we solve quadratics by factoring when a is not 1, which is a lot more steps. So, that's your objective, to solve quadratics by using a factoring method where a does not equal 1, which is going to focus a lot on, the additional methods of greatest common factor and solving by grouping. And to do that, we're going to use the diamond method also. And you guys will see it'll include a lot more steps. So, okay, we're going to start pushing into factoring where a does not equal 1. And this is kind of the beast, all right? In order to do that, we need to review factor by grouping, okay? If you find yourself in a situation where there are 4 terms like this, you can kind of do a double factoring by greatest common factor. And what I mean by that is, jump back to this. All right, this was technically factor by greatest common factor, right? We had 2 terms. We were able to take out the greatest common factor of them. Well, why don't I just do that twice, right? If I have 4, no. If I have 4 terms and I group them, could I do it for each of them? And the answer is that you could. 2x squared plus 8x, the greatest common factor for that is 2x. So I divide out 2x from each of those. And I would get 2x times, 2 divided by 2 cancels to be 1. X squared divided by x is just x. Plus 8 divided by 2 is 4. X divided by x cancels out. You're just left with that. Plus, 3x and 12. All right. So the greatest common factor of that is just 3. 3 divided by, let me put that here, 3 divided by 3 cancels out. You're just left with x. 12 divided by 3 is 4. Notice something here. These binomials are the same. And because those binomials are the same, we can write them once and take their greatest common factors and write them as the other binomials. Now, you probably are sitting there thinking to yourself, that's crazy. How on earth did you do that? You can't just take 2 binomials and write them as 1 and then put their greatest common factors over there. And the answer is you actually can. You have to remember that when we go from terms written out like this to going back to their factors, that at one point in time you had to distribute. If I take this term, watch this. You're all going to think this is crazy. 2x plus 3 times x plus 4. If I were to write out the distribution, 2x times x, 2x times 4. So if I wrote it out, that's 2x times x plus 4. And then 3 times x and 3 times 4. If I wrote that out, that's 3 times x plus 4, right? Now look at this. Isn't that the same thing? Isn't this the same thing as this? I mean, those are identical, right? So when we find ourselves in this position, we know that 2x plus 3 was really just the first binomial that you multiplied into the second binomial. So we can take those and make our factors, okay? Now, where does this work in when a does not equal 1? So let's dive into that, okay? All right, okay. So here we go, all right? This is going to be a little bit longer, and you got to remember that when you get a problem after this where a is equal to 1, to treat it the way you always did for a is equal to 1. But when a does not equal 1, which you see here, it's a 2, we have to do the factor by grouping in the middle here, okay? So I'm going to go off to the side. We have a times c up top, and we have b on the bottom. Notice how a times c, it was always just a c value before when a is 1, but now we actually get numbers. 2 times 3 is 6, right? Because that was a times c, and then b is 7. So we ask ourselves, what times what gives us 6 that adds to give us 7? The answers would be 6 and 1, okay? Or 1 and 6, either way, okay? Now, what do we do with these? We can't just jump into saying this is x plus 6 times x plus 1 like you would have done where a is equal to 1. Because notice when you multiply these back together, x times x is x squared. Well, we had a 2 here. That's a problem, okay? So we use this to split your bx term. We're going to write this now as 2x squared plus 6x plus 1x plus 3. Now, where did this 6x plus 1x come from? So look at this, 6, 1, 6, 1. Okay, we use these numbers that you just found to split your bx term into 2 terms. And now look, you have 4 terms, which means you can factor by grouping. So group, so there should be a plus in between. It's not multiplication, okay? And then factor out the greatest common factor of each. 2x squared plus 6x, greatest common factor is 2x. So we divide that out. We get 2x times x plus 3. And then 1x and 3, the greatest common factor is just 1. But we still need to do that because we need that extra term. And we end up with x plus 3. Now, quick little tip here, okay? If you don't get x plus 3 and x plus 3, you don't get the same exact binomials here and here, you did something wrong, okay? Now, this order that we did here, 6x plus 1, we could have done 1x plus 6x, and we would still get the same exact answer here. So do not worry about that order. If you do things the correct way, you will get the same one. If you don't, you did the greatest common factor incorrect. Now we're going to take 2x and 1. We're going to write it as a single binomial, and then x plus 3 as a single binomial because we know that this step had to have occurred because of FOIL. All right. Remember, we're going in the opposite order of what it would have been if we did FOIL. Now, this is a quadratic. We're not done. This is equal to 0. So you make your 2 equations. 2x plus 1 is equal to 0, and x plus 3 is equal to 0. All right. And then we solve for x. Minus 1 minus 1. You get 2x equals negative 1. Divide by 2, divide by 2. You get x is equal to negative 1 over 2. Minus 3 minus 3. You get x is equal to negative 3. These are your 2 answers. Now, arguably much more difficult. Okay. So let's do another one. F of x is equal to 3x squared plus 10x plus 8. Okay. Identify your a, your b, and your c. Make your x factor. A times c goes up top, so we get 24. B goes on the bottom, so we get 10. Okay. Now, what times what gives us 24? That adds to be 10. And when I look at this, let's see what we got here. 6 and 4. Okay, I was thinking like 8 and 3. I was like, why is that not working out? Remember, you're going to be able to find a lot of different numbers that multiply to be 24, but only one that will also fill the bottom condition. So 6 times 4 is 24. 6 plus 4 is 10. So these are the 2 numbers I need to use to split my bx term. So this turns into 6x plus 4x. Or you could have wrote it as 4x plus 6x. How do you decide which to do? I try to look at the other term. 6x and 3x squared are going to have an easy greatest common factor, just like 4x and 8x will. If I did 3x squared and 4x and then 6x and 8, it just doesn't seem to work as nice to me, but you will get the same exact answer. So I'm going to have 3x squared plus 6x plus 4x plus 8, where then you'll have to factor by grouping. So I'm going to group. I'll make sure to leave that plus sign in the middle. Find the greatest common factor. Greatest common factor, the first one is 3x. So you end up with x plus 2. I'm going to put the 3x on the outside. Okay. Greatest common factor, the next one is 4. So I divide the 4 out. And I end up with x plus 2 again. Good. Don't just make that second one the same binomial if you think you know it. Because, when you divide out the greatest common factor, you want to make sure you get that. Because if you don't, you did something wrong. And then I combine my greatest common factors in one binomial. And then the same binomial as the other. I set it equal to 0. And I solve. I have 3x plus 4 is equal to 0. And we have x plus 2 is equal to 0. Subtract 4. I get 3x is equal to negative 4. I divide by 3, and I get x is equal to negative 4 over 3. And here I subtract 2, and I get x is equal to negative 2. So I have 2 answers, okay? So, no doubt a lot of work when a does not equal 1. Let's go back here for a second. Revisit a problem where a was equal to 1. You didn't have a lot of extra steps. It's a lot easier. You just jump from your diamond factor to solving, essentially. So when you get to these problems, that's got to be the first question you ask yourself is A equal to 1? Because if it is, you have shorter steps. If it's not, you got longer steps. Okay? Okay, here's one for you guys to try. Give it a try, and then I'll go over it. Okay, so hopefully you gave that a try. You make your x factor. We have 6 times 4 up top for negative 24. We have negative 5 on the bottom for b. We have to ask ourselves what times what gives us negative 24 that adds to be negative 5. And the answer to that is negative 8 and positive 3. Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. Okay, so we use that to split the bx term. So we get 6x squared. Now I got to choose. I'm going to put the 3 first because I want to do the greatest common factor with 6 and 3 and then with 4 and 8. So I'm going to go plus 3x and then look, minus 8x. Notice how that negative made it in there? Minus 4. Ooh, I like this one. Then I'm going to factor by grouping. And I'm going to put a plus here. Okay. I'm going to divide out the greatest common factor, which is 3x. And so I get 3x times 2x plus 1. And then notice something here. There's a negative in both of these. And sometimes you have to make that decision. Do I take the negative out or do I not? Watch what happens when I don't. Let's just say I say greatest common factor is 4. Well, then I would end up with negative 2x plus 1. Nope, minus 1. Notice how that's the exact opposite values of 2x plus 1. So we do need to take out that negative. So we should make this a negative 4 greatest common factor. And then we end up with 2x plus 1. We write the greatest common factors as one binomial, and then the other one as 1. Okay, we set it equal to 0. We get our two equations. 3x minus 4 is equal to 0. 2x plus 1 is equal to 0. Add 4, we get 3x equals 4. You divide by 3, and you should get x is equal to 4 over 3. And then here, minus 1, you get 2x equals negative 1. You divide by 2, x is equal to negative 1/2. That's your other answer. Okay, a little bit longer, that's okay. All right, whew, finally made it to the end. What method and when? Okay, a little bit of math talk here. All right, you now know 2 methods. You know, solve by square root, you know, by factoring. Here's a couple examples. All right, if you see this, all right, let me get some red going here. So if you see a missing bx, okay, then solve by square root. Very important. Missing bx, and also if you see something in vertex form. Vertex forms are really good solve by square root, okay? Now we could convert vertex form to standard form, but why? Just solve by square root, okay? Now the next one is, what if you have this? F of x equals, let's do, 3x squared plus 6x. Now you could do the diamond method, but notice how there's a missing c value, and you have a missing c value, and you have greatest common factor. So you want to solve, it's solved by factoring, but you're not using the diamond method. You're going to use the GCF. Okay. Next one. If you have a trinomial, so like an x squared plus 3x plus 4, something like this, okay, then that's where you're going to solve by factoring. And you're going to use the diamond method to do that. Now remember, if a is equal to 1, it's very easy. If a does not equal 1, you got to sprinkle in a little bit of solve by grouping in the middle. Okay. Now lastly, let's just say you have an x factor, and let's make the top number 8 and the bottom number 7. Okay. And you start to look at this and you go, okay, 8 and negative 1 multiply together. Well, they don't actually multiply together to give you 8. They multiply together to give you negative 8. Okay. So why don't I do 8 times a positive 1? Well, 8 times positive 1 gives you 8, but 8 plus 1 is 9. And that's where you might want to try the negative 1, because 8 minus 1 is 7, but 8 times negative 1 is negative 8. Notice how we're not getting anywhere with this. 2 times 4 gives us 8, but 2 plus 4 is 6. If you get to this situation where there is no possible way to go forward, all right, then you are going to need to, then this is a situation where solve by factoring does not work. And I'm going to add does not work easily. There is a number there. You're just not going to like what that number is, and you're not going to be able to figure it out, just in your head, okay? That's a situation where we would use our third method that you're going to learn in 3.3, solve by quadratic formula, okay? So I hope this helps, all right? And, good luck. This is a super long lesson. I'm just going to end the video. Good luck, everyone.